check, 1, 2, okay. So, good morning, everybody. I'm Stavroula, in case you don't know me. And for those who don't, now you have no excuse. I'm from Greece, sunny Greece, plus 18. And I'm here after countless of requests to be on stage and present to you a story about what I do, which is testing telecommunication products in Nokia. Nokia, now I feel very proud I started there because it's the place where it all began. Though I was a bit unlucky that I missed the first training ever when Pekka and Ismo came to visit at our site to show us this new, at the time, testing framework. And I think I'll get over it someday. So, before I start, I would like to say that if you see René juggling here and doing folk dancing, or like a crazy, lanky Dutch guy that's singing the national anthem, it's under control. I'm just having a major panic attack, so call 911. So bear with me. Okay, so throughout my working career, I've been testing telecommunication products as part of a mobile network. Just let me throw in some definitions over here. What is telecommunication? It's exchange of information over significant distances with use of electronic means. What is information? It could be anything. It could be data, voice, it could be video. What are mobile networks? I think we all know mobile networks. We experience them. Even now in this room, when you're all looking at their phones, you're looking at me. So I'm just going to give you a small top-level architecture of a mobile network. As you can see, there's a lot of stages between the end user and the destination. So one request basically goes to an antenna, then to other bunches of antennas, and then to other servers, and then finally to a core network, and then internet drives to data centers or cloud. I promised I will not say a lot of things, a lot of details into this thing. So I will only say that what we're focusing now is the transmission of information between all these antennas and up to the core network. But then you will tell me, where do microwaves come into this? That's a wise question. Well, microwaves is a form of electromagnetic radiation, one of the 7 types of electromagnetic waves, with wavelengths ranging from 30 centimeters to 1 millimeter. So that's like frequencies up from 1 to 300 gigahertz. They travel by line of sight, so unlike other lower frequency waves that they diffract or they reflect in the Earth's atmosphere. So they need to have a point-to-point link to be transferred. Microwave transmission is used everywhere. In modern technology, telecommunications, transportation, like for traffic monitoring in railways or airports. It can be used in medicine, and of course, the most important, cooking our food. So we use microwave radio frequencies to create a point-to-point link to transfer data over significant distances without the use of physical cables. So in the pole, we have an outdoor unit which is connected to the antenna, and that is connected to an indoor unit. So all these, of course, you can understand, can form many networks based on the network provider and different network topologies. Some of them you might recognize. This is like a ring topology, which is used for network redundancy. So all of our the hardware units should support those specific features. Some use cases are if you want to increase your capacity in suburban areas, if you have very difficult links, like if you want to connect islands together, or to send information over the mountains or through a desert where it is very expensive to set up fiber optics. Or when you want to have redundancy, so when you have a complementary to a fiber network, in case of network outages. I guess you all know this, you have seen it when you've been going up in a mountain. This is a microwave telecommunication pole. Now you can show off to your friends, you know what it is. It contains, you can see, of many antennas, so you can understand that this is a part of a really, really, really big network. So then, how do you test that? We need to test actually radio transmission, wireless transmission over a network. So no, we don't go into 2 different buildings and we just send information to each other, but that would be really cool, but we don't do that. I would say this is quite similar, more simple, to a network switch. So if your product was a network switch, what would you do? You have a configuration interface, which is the web API, right? So that's what we do. And you have Ethernet ports, and you know what they do. You just have to send the data from one port to the other. But what will happen if one port stops transmitting? And of course, you have to test all kinds of ports, every port, because one may malfunction. Or there's the hardware platform underneath suddenly has a buffer overflow and it just decides to drop some of the packets. Or there's a network of switches where there's a lot of data coming in and some of them are dropping, you don't know why. So these are just like very simple cases that we have to deal with testing hardware. But imagine when all this goes to a more complicated hardware like a radio antenna, and of course all of its connected units, as we said, the indoor and outdoor. And I didn't tell you, we have like a dozen different hardware types, so we have to test all of those different hardware types and different ports. So that's really, really difficult. So that is how I felt 2016 when I first entered this product. And testing at that time was not a priority. There were manual testers, there were people from the 90s, the Visual Basic, and there were some people migrating to Python 2. They were using TXT for output reports, so that was like taking a long time to identify the failure. They had made custom GUI from Visual Basic, and some of them were also using a testing framework, which I don't want to say which one it is, but it's green and it's a side salad. Good, I'm glad some of you laughed over that. Okay. So you can imagine that there was like code duplication everywhere, like it was mayhem, and I was like, I have to do something about it. So I summoned two of my other colleagues in secret, and we forged a master testing framework to control all others and to replace it and to enforce it to the product. So into this framework, we said we kind of have some goals. We want to have it global. We want all the teams to use it. We have to cover all of their needs. We want to have them, the tests being readable by everyone, and also to enable testers to write tests easily. That is important because our testers at the time were evolving with the product. So we were like having 30 years testers that were, because the product is around 30, 40 years, or maybe even more. And they knew a lot about the functionality, but they didn't know about automation, so we had to enable them to write easily tests, have to persuade them. Of course, we needed to have the testing results in a readable format and easy identification of the failures, and we had to integrate it to our CI/CD pipeline, which we just started to implement. So we were like writing it down, and we were like, hey, wait, this is Robot Framework, we can use that. Great, let's try to have a simple testing scenario. So each tester has a network of hardware units that he has to test. So what he wants to do in one hardware unit, he opens a browser, he types in, we will call the hardware unit network element, because it's an element that belongs to a network. He types in network element's IP, logins with the user profile credentials, does what he wants to do, checks that it's done, and then closes the browser if needed. And now I know what René and Tatu and everybody will say, this is Selenium library. Yeah, it is. But that was back in 2016. I think Selenium library was Selenium number 1, and then it was being underdeveloped. And at that point, we had also a lot of problems with testing the web page, because we had to do some workarounds inside the code, because Selenium didn't work on our web page. So we decided we're going to use Python to do all these functions. So we said, okay, yes. We will use the keywords to describe the steps of a test scenario so it can be easy to everybody to follow. So we will have some actions like the one to get the alarms of a network element or create a VLAN, so it can be easily understandable. So what will happen though if the tester wants to apply this test scenario that we did to his other network element or to his fellow colleague network element, which could be different. So we said we don't want to have duplicate tests. So we said we're going to have a variable file where it will contain all the dynamic parameters of the testing unit, that IP, type of hardware, the topology that it's in, and other things I'm not going to go into much detail. And all of this is structured in one class object. So accessing one name, one object, can give you all the information of one bench, one network, yeah. And that's why we can apply the same test just to a different bench. So that's very powerful. But wait, oh yeah, just as an example here, really, really simple. So we just replace it with a variable. But wait, it gets worse. We also have different interfaces to test. So we don't have only the web. We have also an SNMP interface. I don't know if you all know about SNMP. It's an internet standard protocol that manages information on devices and IP networks. So it's actually a configuration interface, so we have to test that as well. So if we go to the previous example, the web, the SNMP, you can see that we have like similar steps. But that will mean we're going to have two types of tests and two types of keywords. And we didn't want that because they actually do the same thing. So we thought we will use one keyword for one action. So what we said, I'm going to give you an example. We said we're going to put a an argument, in the keyword that will specify which interface we want to run. So if you go into the keyword definition, you will see that that argument is actually running the Python function underneath. So in this way, with the same keyword, we can run at the same time we can run it in both interfaces. So, but there's the thing. If we write everything on all these things, all these steps on the Python function, then we'll have some unnecessary action because all the actions you want to do, for example, if you want to do it on a web, you have the WebDriver open, right? Or if you have it, or when you do it to the SNMP, you have the connection open already. So if we say that this is the one action that we want to describe, then all the above are the prerequisites. So we have to find somehow a way to put them into our test. So we thought of decorators, Python decorators. Okay, so as an example again, we get the active alarms of our network element. You can see that we have the argument is IP, but the Python function takes the WebDriver because, as we said, the actions are on an already open WebDriver. So we have the decorator, which is IP mapping right now, which handles all these prerequisites. So what it has done, if it says that if the function starts with web, then I'm just going to go and check if it's an already open WebDriver and return the WebDriver object. If nothing is open, then it will open it and it will return, log in, authenticate, and then return the WebDriver. So similarly, for SNMP, we ensure that the connection is open, but as you can see, there's one more argument over there, which is the SNMP version, because the SNMP protocol defines a version where it's sending its commands. So this we decided in order to put a lot of things into the keyword, to read it as a runtime variable or a global variable, and to put it hard-coded inside the Python function. So that's what a decorator does here for our two interfaces. So we actually managed it. We did everything. So we have one test suite, one test, and can be run to any hardware unit. It can be run to any interface. And it doesn't need to write all these things like open, close, browser, and all the other things the other interfaces. So this is a simple scenario where I have the variables that are set on runtime, which is the interface you want to run in the browser. Then I just put some variables here that are on the variable file, just for simplicity. So for example, the IP or the hardware type. And this is a scenario where it downloads and activates a new software package on a network element. So this actually test can run everywhere. So we have one test. Everybody can run this, and that's it. Other challenges that we faced. We have to handle external hardware. Most importantly, we have to have traffic instruments to simulate the real network traffic. So again, we had to test that because we had to create keywords to handle the CLI commands that they provide, and to create, of course, simple keywords so everybody can understand, like start traffic, evaluate traffic, see if something is dropped. And so we had to actually do like a small different framework inside our own framework to test that. And of course, we had other hardware like power switches or serial switches, so we can help us to all of this, because we have to gather logs from everywhere and check all the logs from all the hardware and to gather any other, to do any other tests. One other challenge that we faced is the automation browser testing. I think you've all experienced, well, all of you have worked with testing of web pages, is when the browser gets updated. But okay, that sucks when it happens by itself. So what we thought, because we needed a stable version, is to use a portable apps. It's a portable version of the browser, which is stable. It's just a standalone app program that can run from the computer. So in each release that we have a specific release of a browser. It never changes. And that's good because when our web page evolves, then if we want to run, for example, something in the previous release, we have that browser that we know that it worked. And because we don't know if the new browser will work on the previous release. And I don't know if you know now, Google has officially released a Chrome for testing browser, which is stable. And that means that we're heading the same way. So that's good. So other things that we have incorporated are the parallelization of test cases and test suites. So we can, for example, run something in parallel, like the previous test we could run in parallel and just download the software in all our network units, which could be 10, 12, 13, I don't know. So we can run in parallel and save time. We have also created dynamic test cases. This is usually, the applications we have is when we want to have a test and test different traffic types, different scenarios. So these are dynamically created then, based on a file. And so this is our top level of automation framework. You can see we have the framework test on top. It's connected to our Jenkins client. Underneath, we have the Python functions. Python functions call the standard libraries, the Python libraries. So we have Selenium to test the web. We have PySNMP to test the SNMP interface. And as you can see, we have now ongoing implementation of netconf, REST, and CLI. And this is how easy you can see that, how easy we can expand our framework to different interfaces, because we have to support all of this. And just by writing the Python functions, we don't have to change our tests, which is very important. So summing up, the basic, our main principle is like the one keyword approach. This leads to test readability, test adaptability of network topology and hardware specifications. Then the user is happy because he can read and he can write a test easily. And of course, we can expand easily, and it's easily maintainable, expand easily to new interfaces. So where do we go next? Well, apart from the new interfaces we just mentioned, we can use simulators to test specific parts of hardware. we want to try to have a new challenge, which is the system on chip. So we want actually to test an ASIC board, any of you know. And then, who knows? We have a lot of requests and a lot of things to do. I want to thank everybody who believed in me and with my friends that we started this project, and everybody who supports me. And I thank you for listening to me, and I'll take your questions now.
Excellent talk, and here's a hoodie for you. Oh. You have a microwave.
Yeah, I have my microwave here, sorry.
Like t-shirt, talk-specific t-shirt. Yeah. Let's give a warm applause. Oh, that's awesome. Do we have questions in the audience? Raise your hand, there's one.
Thank you. Thank you for the awesome talk. One question, really familiar to me as well. I've been in Nokia as well doing similar things, but you have often this situation where you have, for example, this keyword, get logs from, let's say, some router.
Yes.
And then a new version of the router comes. Okay, now you have two different routers. They might have a bit different, for example, command, how you get that logs. Then third, fifth, then you have 10 different equipment where you want to use the same keyword to get logs, but all of these devices have their own unique command, for example. So is this issue familiar to you, and in which ways you should solve that?
Okay, yes, we have some similar issue. There are not so many differences because we tell our developers to at least write some key codes so we can get, of course. We use regular expressions a lot. And what we do is, if it's something very, very specific, we just write it in the Python code and we say, okay, if we go to that machine, let's say that version, we want that. That's it. It's not so advanced. Yeah.
Next question. Do we have more questions? There.
The one at the back over there.
Hello, thank you for the talk. I would like to ask if you have some kind of reliability or stability tests to verify if the packets are being transmitted and in what success rate by the microwave setups.
Of course. We every 2-3 days we have stability tests that run for 2-3 days with with a lot of different types of network traffic, and they're trying to stress our hardware units. We also have tests where we have our hardware units inside a climatic chamber, so we can simulate the different temperatures, because as you saw, there were some up in the mountains, and the temperatures could be like -50. So we have to be sure that everything works well there, so the transmission as well. This is everything, and we don't have any packet loss. So yes, we do that.
More questions? I think we have at least time for 2. Raise your hand if you have any. There's none in the slide. No, there's one. Yeah.
You told us, first of all, thank you for the great presentation. You told us that you had to automate and to add libraries to Robot Framework to control traffic generation, like, I don't know, Ixia or ByteBlubber or whatever you use.
Yes.
Did you think about publishing it and making it open source so everybody will be able to use it?
No, but that's a good question. We can do it then. Yeah, why not?
Idea for a talk for next year.
We have Ixia and Anritsu and Vix and don't remember, there's many more. You can come and find me and I'll show you which ones you want.
Pressure her to open source.
Yeah, pressure.
One more question. Anyone? Yeah. There. Good.
Great talk. So with the concept of the one keyword, and if you, one of the questions I have is if you narrow down how much keywords there are, it's always a question of finding errors. Do you have a problem with kind of figuring out which error is it, or does the errors kind of easily bubble out from what you've got designed?
They're quite easily to find. We had some errors when there were an updated version of the web page we construct, which is especially with Bootstrap. That was horrible. I don't know if you know, everybody knows about Bootstrap. It's a CSS framework. And that was a bit weird because it was a bit unexpected behavior. And that's why we had to do some hacks on the code. That was a bit, but apart from that, everything is quite straightforward. Robot is helping us very much. We just put the errors on the HTML, on the report, and it's easy.
Thank you. I have one question. What's your favorite microwave food?
Popcorn.
Popcorn. Yeah. That's good. That's good. Hey, give a big hand, Stavroula Ventura.